All right, so wrapping up chapter 2, we're going to go ahead and take a look at what do we do when we solve rational inequalities. If you have a really good understanding of how to solve the polynomial inequalities, then this is really just going to be the same thing. By having you sketch out a graph of the rational function, that is really your best bet to be able to look at this. So that's the way that I'm going to go ahead and be showing you this. Before I get started with the rational inequalities, what I want to do is just go over a polynomial inequality and how we're going to find, the equation and then the two inequalities being greater than or less than. So again, the easiest thing is just think about, your polynomial and sketch out a graph of it. So by looking at my three factors here, I can identify where my zeros are. I have a 0 at 0. I have a 0 at -3. And then I have a 0 at +2. And from this, when I look at this, I see three zeros, but one of them is a multiplicity of 2. So altogether, we have 4 zeros, which means that we are going to be having n behavior that's going to go up to positive infinity. So when I think about graphing out my function here, I've got to be real careful because at -3, I'm going to bounce off of my graph. Then it's going to go through 0, and then it's going to come back up through 2. So when I look at my function, when is it equal to 0? Well, that's going to be when x is equal to -3, when x is equal to 0, or when x is equal to +2. When is our function going to be greater than 0? So the reason we have this graph is so that we can easily see where the graph is above our x-axis. And I see that it is above our x-axis here when x is less than -3. I see that it's between the interval of -3 and 0. And then I also see that it's when x is greater than +2. Now you might be asking, why am I not just putting for over here, why am I not just saying that it's greater than 0 when x is less than 0? Well, the only thing is here at -3, it's equal to 0. And our inequality here is when is it greater than 0. So if it was greater than or equal to, then I could say that's all the values that are less than or equal to 0. But here we don't want to actually include that -3 for it. All right, when are we going to be less than 0? So that's the lower x-axis here. And that's going to take place for when x is greater than 0, but less than 2. So that's just a review with your polynomials. Now I'm going to go ahead and just take a look at a rational function. For time purposes here, I've already got it factored out for us. So I'm going to go ahead and look at my denominator right here, and this is going to help me identify where my asymptotes are. And so it looks like I have an asymptote at -6 as well as +2. So here's -6 and here's +2 for my vertical asymptotes. I see that I have a 0 at -4, so I can go ahead and place a point here at -4. As far as my horizontal asymptote goes, if I look at my leading terms here, I've got x as in my numerator, and then I'm going to have x squared in my denominator. So that tells me that my x-axis is going to be my horizontal asymptote, since larger numbers in the bottom. And then lastly, I'm just going to go ahead and find my y-intercept, because sometimes that can be really helpful. Plugging 0 in for x, I end up with 4 is over 6 times the -2. So that's going to end up giving me 4 over -12. So I'm going to have a -1, -1/3 is going to be my y-intercept. So there's -1/3. And so with that, now I have enough information here to go ahead and say that I've got a line. It's going to go through my 0 at -4 and my y-intercept of -3. With this graph here, if I test out a point that's greater than 2, I know that I'm going to be in the positive area here. And then over here, I'm going to be in the negative. All right, so now I'm going to look at this graph here, and I'm going to identify, well, first of all, when does our function f of x, when does it equal 0? There is only one zero for that, and that is only when x is equal to -4. Next, when is f of x going to be greater than 0? So again, we're just going to, just like with a polynomial, we're going to look for when is it above our x-axis. And I can see that it is between two intervals here. And we're looking for when x is less than -4, but it has to be greater than -6, and that's that vertical asymptote that we have. Also here to the right, we're looking at values of x that are greater than +2. So you're looking at your x values to help you come up with your intervals. When is our function going to be less than 0? So now I'm going to take a look at when is it below the x-axis. And the intervals of where that is happening is when x is less than -6. That takes care of that for our end behavior. And then also we have for when x is going to be greater than -4, but less than +2, and 2 being one of those vertical asymptotes. So very similar to working with our polynomials. Let's take a look at another one. Here, as I look at things, I'm going to go ahead and try and find all the information I possibly can. So I'm going to go ahead and try and find my asymptotes first. So it looks like I have an asymptote at -4. And it looks like I have an asymptote at +3. And as far as our zeros go, we have a 0 at -2. And we have one at +5. Horizontal asymptote, when I look at that, if I were to FOIL this out, I would see a leading term of x squared. Same thing on the denominator, so that simplifies to 1. So I'm going to have a horizontal asymptote at 1. And now if I go ahead and I look, I should actually find my y-intercept real quick. My y-intercept up at the top, I'm going to end up with -5 times a +2 over 4 times a -3. Again, I'm just putting in 0 for x. So this is going to give me -10 over -12. So we could simplify that to +5/6. So +5/6, we're going to be about right here. So now I'm going to go ahead and just graph things out. I have to go through that 0 and that y-intercept. And over here, I have another 0 that I need to go through, as well as my end behavior has to go towards +1. Choosing a point that's less than -4, I would see that I would be in the positive range for that. So now we're just going to go ahead and answer a few questions. Commonly, when is f of x going to equal 0? Well, that's going to happen when x is equal to -2 and when x is equal to +5. Those are our only zeros. When is f of x going to be greater than 0? So I take a look at my function, and when is it above our x-axis? And so I see that there's 3 different intervals that it is above that x-axis. We're looking for when x is less than -4. We're looking for the value of x that is greater than -2, but less than 3, as well as x being greater than +5. Lastly, when is our function f of x going to be less than 0? And it's going to be less than 0 at this interval here. And so we're taking a look at x is going to be, it's going to be greater than -4, but less than -2, as well as x being greater than +3 and less than 5. And there's our intervals. So very similar to what we were doing with our polynomials. What I'd like you to try and do here is try and see if you can do this one on your own. I'm going to go ahead and pause my video. I want you to pause it too. Try and see if you can figure this one out on your own, and then start it back up and then see if you've got the correct answer. All right, so here we are with this one. One thing I just want you to kind of think of when you look at your graph is notice what your end behavior is. When you take your leading terms right here, you would get an x to the third divided by x squared, so that ends up simplifying to x. So our end behavior is going to represent kind of our linear function, so it's going to be going towards positive infinity as x gets big and negative infinity as x gets small. So finding our zeros as well as looking for when is it increasing or decreasing. There's 3 increasing intervals and there are 3 decreasing intervals. Lastly, I just want to take a look at a type of function where we're going to include just some absolute value. Just kind of having you guys take a different look at something like this. And the big thing about this one is, thinking about your asymptotes here, we've been seeing things mostly as factors, and now I have x plus 5. Now, again, we can't divide by 0, so a lot of you are going to go ahead and say, okay, I've got a 0 at negative 5, but we also have, when we come up with that, when we come up with our 5 here, so that's going to be where our vertical asymptote is going to be. Since we have negative 5 plus 5, that would be 0, and the absolute value of that is going to be obviously 0, so we can't divide by that. As far as our 0 goes, we're going to be at positive 2. So we're going to have a 0 at positive 2 here. And when you start thinking about your end behavior, it's going to be a little bit more, difficult to be thinking of because we haven't had anything with this absolute value. So what I'm going to go ahead and do here is I'm just going to kind of plug in some values to see what our graph is actually going to do during this time. So first of all, I only have this 1 0 that's going to be there. So I'm just going to grab my graphing calculator. I want to have this being started as we look at it, as it's loading here. All right, so taking a look at a type of graph like this. First of all, I'm just going to take a number like that's less than negative 5 and see what's going to happen in that area. So, for example, negative 6. So if I think of f of negative 6 minus 2 would give you negative 8. And then negative 6 plus 5 would end up giving me negative 1, but the absolute value of that is going to be 1. And so here I would get a negative 8. So if I think about here, negative 6, I would be at negative 8. If I just kind of think about, I'm going to be below that x-axis. If I pick a point between 0 and negative 5, I'm going to go ahead and just pick negative 1. Negative 1 minus 2 would be negative 3. Negative 1 plus 5 is 4. Absolute value of that is 4. So that gives me a negative 3/4. So that's going to keep me below my x-axis again. So at negative 1, I'm at negative 3/4. Picking a number between 1 and 2, so I'm just going to go with a positive 1. And I get 1 minus 2, so that's a negative 2. I end up with 1 plus 5 is going to be 6. Absolute value of that is 6. That continues to be a negative 1/3. So I'm going to, negative 1/3 is going to be less than or greater than negative 3/4 there. And then lastly, I'm going to pick something greater than 2. So we look at f of, say, 3. 3 minus 2 is 1. 3 plus 5 is 8. Absolute value of that. And all of a sudden now I get this positive of 1/8. So at 3 here, we're at 1/8. So by the looks of this, it looks like something that's going to happen with my graph is we're going to have something that perhaps resembles this on the right-hand side. And on the left-hand side, I'm kind of thinking it's going to go along this way. The reason why I'm thinking it this way is because I only have 1 0. So I can only cross my x-axis at that one point. When I look at my 2 points that are to the left here, they're both negative. So that means I have to come up along this vertical asymptote, pass through 2, and then go to the positive. On the left side of our vertical asymptote here, I have a negative answer as well. I do not have any zeros that are going to be here, so I can't cross over that x-axis. So I'm just going to go to our calculator real quick. I just want to show you this here and see, does it resemble what I have? In parentheses here, I'm going to go ahead and do x minus 2. And then I'm going to divide by the absolute value. of x plus 5. And then I'm going to graph it out. And then there we are. You'll see that this graph kind of resembles it. Now, my graph is kind of going up straight here where the computer module is kind of going more this way. And that's perfectly fine. I'm trying to sit here now and look at the inequalities. So when is our function greater than 0? When is it less than 0? So when f of x is greater than 0, I can see that it's only greater than 0 for when x is greater than positive 2. As far as when our function f of x is less than 0, we're going to be looking at being below this point here. So I have two values that are less than 0, or two intervals, I should say. So x is going to be greater than -5, but less than positive 2, and also for when x is less than -5. So there it is. That was a good 16 minutes for you guys to look at how do you graph rational inequalities. If you do have any questions, make sure you jot them down and bring them to my attention tomorrow. So thank you.